Hi, my name is Josh Nolan, and this is my homework 6. Okay, 6-92. We had to find properties of air at a certain point using table A15, and then we had to assume that air was modeled by a ideal gas to get density at that specific temperature and pressure, and then we used an equation in Prandtl's number to get a heat transfer coefficient. Okay, so 7-28, we used air properties tables again to find the kinematic viscosity and Prandtl number, and then we're trying to find the speed of air as it goes over the surface. We assumed steady state. Reynolds number was equal to 5 times 10 to the 5th, and that the properties remain the same throughout the trial. Then we found the Nusselt number, Reynolds number, and then we solved for V in the Reynolds number equation. Okay, 8-91E, we have a pipe that's being radiated, and we had to assume that there was the glass didn't really affect the heat transfer, so there's negligible thermal resistance. And then we also assumed steady state. We also assumed an average temperature, which is a little confusing to me because we talked about log mean temperature difference, and this seems like an application of that, but we didn't do that. We found density and K values, and then we used Q equals m dot Cp delta T to find what the Q required would be, and then using that and the Reynolds and Nusselt number, we found H, and then using that and the equation that related length and Q, we found the length, and then we found the temperature at the end. Okay, for the next part, for the next one, 9-143, there's a box, and it's naturally convecting air through its sides and the top, and we assume that no heat is being transferred from the bottom. And then we found the characteristic length. We found the Rayleigh number, which I'm a little confused on. I don't even know what that is. That was a solutions thing for sure. Then we use Nusselt number, and then we found the relation between Nusselt number, and we used Nusselt number to find H. Then we just used Q top equals HA times delta T to find Q from the top. And then we do the exact same process for the sides. And then we do F equals the Q dot over Q dot total. Find 16% is being evacuated from the sides and the top. For the next one, we found 2 heat transfer coefficients in the middle and the bottom of a vertical plate that is having stuff condense on it. We're assuming steady state laminar flow and uniform temperature, and then we find water properties from table. We use HFG. I don't really know what that equation. Oh, that was just for never mind. I don't know what the equation is. And then we use this equation, and then you can plug in because we get Hx equals 4008 times 1 over x to the 4th. Then we just plug in our x values. We get 7130 and 5990. Thank you.